next is how do you determine whether at this 0 right here is our function going to be that factor to the first, to the second, or to the power of 3? Right? And so that is called multiplicity. And so the three cases of the multiplicity of zeros that we're going to look at is 1, 2, and 3. Right? If a graph has a multiplicity of 1, and that means it's going to be that factor to the power of 1, what's going to happen is the graph will have a tendency to pass through the x-axis in what seems like a straight line. Okay? So if your graph passes through at this point, I'll go through a point. If your graph looks like this, it passes where it's almost like a straight line passing through, then this factor is going to have a multiplicity of 1. Okay, if that graph turns around and comes back down in this form, once again, you're looking at a multiplicity of 1. A multiplicity of 2, what's going to happen is the graph is going to change direction at that intersection. So if we have a graph that comes down and it touches and then bounces off, where it has the little shape of a parabola, that's going to reflect a multiplicity of 2. That means that whatever this factor is, when you expand your function or turn it into a function, will have been included twice, right? Or an even number of times, but we're going to be using just 1, 2, or 3. Again, it might change here and come down. Let's say it passes through like this. This would indicate a multiplicity of what? If it passes all the way through, almost in a straight line, it's 1. And then if it comes back and it bounces off, then this right here is a multiplicity of 2. Again, if it looks like a parabola at that 0, then it's going to be a multiplicity of 2. And again, coming back here, this is multiplicity of 1. And the circled ones are multiplicities of 2. Okay, a multiplicity of 3 means the factor is going to be cubed and not to the power of 1 or the power of 2. So here, if you have a graph that passes through and it looks almost like the curve, the sort of S curve of a cube, perfect cube. So now it's not straight through. Now it has this sort of curve to it. This is going to be a multiplicity of 3. Okay, so if the graph continues, comes here, bounces off, this would be a multiplicity of what? 2. If it comes back down like this, it's going to be a multiplicity of here. Again, it has that sort of S curve to it, 3. And if it comes back up straight through like this, this would have a multiplicity of 1. Okay, so again, this right here would be a multiplicity of 2. This would be a multiplicity of 1. And then each of these are multiplicities of 3. Like I said, each of these is a multiplicity of 2. And each of these is going to be the multiplicity of 1. Does everybody kind of see the distinction between those? What the graph kind of looks like as it goes through? Okay, so what that means is at this 0 right here, there's going to be, or let's say right here, so at 1, 2, 3, negative 4. So this is the factor x plus 4. We're going to see a multiplicity of 3. So the factor that corresponds with that part of the graph is x plus 4 cubed. Here at this x, at x, what's going to happen here? This is x to the squared. And then here we have 1, 2, 3, 4. So x minus 4, what's going to happen here? Cubed. And then finally 5, 6, 7, 8, let's say. At x minus 8, it's going to have a multiplicity of 1. An unwritten 1, but I'll write it there. And so this would be your function. And so you can identify, and we'll be able to expand out our functions and find what the equation is of a graph based simply on the multiplicities of the different zeros. Okay? And then the sum of the multiplicities for what we're going to see is the likely degree of the polynomial.